Stoke's theorem. What is Stoke's theorem? This is one of the basic definitions of Stoke's theorem. Stoke's theorem says that line integral of a body is equal to its surface integral. When I take a line integral of a body, it always equals to its surface integral. So basically, Stoke's theorem defines the relation between line integration and surface integration. When you reflect back to the previous session, Green's theorems also relates line integral to its surface integral. But there is a main difference between Stoke's theorem and Green's theorem. The difference is that Stoke's theorem applies on the region lies in 3 dimensions, where Green's theorem applies only on a plane region in 2 dimensions, not in 3 dimensions. This is the main difference between Stoke's theorem and Green's theorem. Formula of the Stoke's theorem is here, where line integral equals to the surface integral. Looking at left side, where C stands for the curve, for the boundary of an object, for the outline surface of an object, where A stands for the surface, the region under the curve of that object. Suppose that this is my object and I want to apply Stoke's theorem on it, where the border or the line shows the line integration on the left side, where the red area or region is the surface integration on the right side of the equation. dr is actually vector of resultant vector. Look to the object. It is actually the tangential vector of the resultant vectors on the curve of a body. At the right side, f is actually the vector point function. It's a vector in 3 dimensions. Let me take xyz plane. Let me take an object here. It is in 3 dimensions because it has coordinates in all the 3 xyz plane. N cap is the unit normal vector. Let me draw xyz plane again. These are the unit normal vectors I, j, and k. I is along x-axis perpendicular to yz plane, and j is along y-axis perpendicular to xz plane. K is along z-axis perpendicular to xy plane. ds actually represent dx, dy, or dz. If I take an object in xyz plane, then ds will be dx times dy. If I take an object in x and z plane, ds will be dx times dz. But if the surface is in y and z plane, then ds will be dy and dz.